In section 12.1, you learned that it was necessary sometimes to simplify a function before you differentiate it in order to get it in a form that matches those rules, such as sum and difference rule, power rule, constant multiple rule. We're going to learn in section 12.2 that if your function happens to be the product or quotient of two functions of x, you can differentiate it directly with special rules. So take some time to learn the product rule, go through examples 1 and 2, then take some time to learn the quotient rule and work example 3. Remember, these are worked out in your textbook or in your e-textbook. When you get ready to work example number 4, restart this video and I'll go through this one with you. If you're ready at this point to work example 4, let me just warn you here, this is a tough problem. This is probably just about as bad as it's going to get. This one requires both the quotient and the product rules in one. Now, I worked this the first time and I ran out of space here, so I'm going to flip over and get some extra workspace. You may want to work this on the back side of your notes, or if you get started and you run out of room, just include a sticky note there. So our problem is to find the derivative with respect to x of, notice in the numerator, we've got the product of two functions of x, and in the denominator we have just a single factor. So we have a quotient which also involves a product. So we'll begin with our quotient rule. In the quotient rule, the first thing that we want to do is square the denominator. I like to always start by squaring the denominator, because that reminds me that's the same function that I begin with in the numerator. So the pattern of the numerator will be the denominator times the derivative of the numerator minus the derivative of the denominator times the numerator. Now I'm going to map this out and plan it out and go back and actually execute the derivatives on the next step. So I've got my denominator. Now I'm going to multiply by the original numerator's derivative. So I have 3 minus 4x times 5x plus 1. Just going to call that prime. So the plan on the next step is to go back and find that derivative. Remember, the quotient rule has a minus, where the product rule has a plus. So we have minus. Then we're going to find the derivative of the denominator, and then multiply by the numerator as is. So we have 3 minus 4x times 5x plus 1. So our pattern is denominator times derivative of the numerator minus derivative of the denominator times numerator. That's the quotient rule. When I go back to actually execute those derivatives, I notice that right here I've got the product of two functions of x. So when I get ready to find that derivative, I'm going to have to apply the product rule. Now again, I'm going to map it out and plan my steps before I actually execute the derivative, just because this is sort of a tough problem. So I have the factor 7x minus 9. Now I'm going to apply the product rule to what's in brackets here. We have the first function times the derivative of the second, which I'll just denote with a prime, plus, remember product rule has a plus, the p in product goes with the p in plus, the derivative of the numerator, or the first function, times the second function. So that's the plan for differentiating that product. And for now, I'm just going to copy down the rest of the details, and we'll go back and actually execute those derivatives on the next step. So now everything is planned out and ready to go. The first round, we applied the quotient rule. The second round here, we applied the product rule. So let's go and find those primes. So in this set of brackets, I've got our first function, 3 minus 4x, times the derivative of 5x plus 1, which is just 5, plus the derivative of 3 minus 4x, which is negative 4, times 5x plus 1. Now we're ready to differentiate 7x minus 9. We would obtain 7, and then we have these two other factors to carry along. Now the good news is, at this point, you are done with the calculus. You have found all of the appropriate derivatives. But we still have to simplify it. So we have to do quite a bit of algebra to simplify this expression. So I'm going to begin simplifying by working on this element inside brackets. Inside brackets, I want to distribute the 5 and distribute the negative 4. When I do that, I can demote those brackets to parentheses. And multiplying, we obtain 15 minus 20x minus another 20x minus 4. Over here, the next thing I'm going to do is FOIL those two binomials. That's going to give us 15x, outside terms would be plus 3, inside minus 20x squared, and last minus 4x, all divided by the square of the denominator. Don't forget to carry that denominator through to every step. Don't leave it behind, because sometimes you can forget it if you do. Okay, let's work on simplifying what's inside parentheses here. We'll combine like terms here and combine constants here. So we end up with 7x minus 9. 15 minus 4 gives us 11. And combining minus 20x, we get minus 40x. So we have 7x minus 9 times 11 minus 40x. Next, we can combine like terms here. And let's also lead with our highest powered term. So don't forget coefficient negative 7. Then we have negative 20x squared first. That takes care of that term. Combining like terms, 15x minus 4x, we get plus 11x. And then we still have a plus 3 there. Now it's looking better with every step. Let's drag this denominator along. By the way, don't multiply out your denominator. Leave it squared, just in case we can reduce it later on. But we do want to multiply out our numerator. So the next thing I'm going to do is work on foiling this first set of binomial factors. We have 7x times 11, which is 77x. Outside terms, we have 7x times negative 40x. That's going to give us negative 280x squared. Inside terms, minus 9 times 11 is minus 99. And last, we get plus 360x. Next, let's distribute the negative 7 into this set of parentheses. That's going to give us plus 140x squared minus 77x minus 21. Hang in there, we're almost there. If your brain's getting tired and the arithmetic gets hard, grab your calculator and verify all of these numbers. Okay, let's take a look and see where we can simplify. First thing I spot here is positive 77x minus 77x. Those cancel. Let's combine negative 280x squared plus 140x squared. That's going to give us negative 140x squared. Next term we should include would be this plus 360x, so that we can have it in descending order. And then we've got a couple of constants to combine. We have negative 99 minus 21. That gives us minus 120, all divided by 7x minus 9 squared. So this is the derivative of that original function. Again, that one's challenging because it requires both product and quotient rules on one problem. If you understood that, you followed the calculus and you followed the algebra, that's awesome. You may want to try and practice it on your own, see if you can work that problem over again on your own. Now when you go back and you look at problems where you just have to do the quotient rule or you just have to do the product rule, they don't seem so bad. All right, keep working hard and I'll talk to you in the next video.